Hey there guys, welcome to my linear algebra series. This is going to be my intro video. I basically, today, randomly, as usual, I get on Reddit and what do I see? I see that there's this new thing called the Reddit University. I looked into it deeper and it really, to say the least, really piqued my interest. I saw that, there were some mathematics and programming courses, but I thought, hey, I know some things, and, obviously there's people on the subreddit that are also interested in learning these things, so I thought, why would there be a reason for me not to, add to the community and maybe start making some videos in regard to mathematics? Probably what I'm going to do is I'm going to start with linear algebra. We'll see how this course goes, and then we'll, grow from there. At the moment, I'm looking forward and seeing I can't see a reason why I want to go further. Probably, right now I might do linear algebra, and then later I might do programming, I think Python might be really cool. I saw on there's some guy doing C++. That seems really awesome. But yeah, let's get back into linear algebra, and let me just give you kind of an outline what I'm going to be doing, what you can expect out of this class, and yeah, so basically why we care about linear algebra is because basically, all systems can really be simplified into, linear guys. These are kind of the equations, we kind of started with that we could actually solve. When you look at mathematics in like a general sense, really all we know how to solve are, what we know how to solve very easily are linear equations and quadratic equations, but what are your quadratic equations? I mean, they're just two linear terms multiplied by each other, right? So even quadratics can be simplified into, linear terms. This linear algebra, I mean, maybe later I'll do like a multilinear algebra when you get more into like the, different, well, I don't even want to really go there, but linear algebra, what we're going to be dealing with, very nice matrices and nice transformations so that they don't really get confusing. I mean, I might do someday, just brainstorming here, like topography or something like this when you're looking at, more advanced linear transformations where, you're actually taking some sort of shape, let's say a sphere, and you're like turning it inside out via, transformations. But that's another thing for another day. But basically, for linear algebra, what we care about is solving, linear equations. That's basically what we do in linear algebra. And, basically in this course, we're going to be talking a lot about, vectors, how to solve linear equations, matrices, eigenvalues, eigenships, determinants. What I hope to do, I mean, what I feel like in this, at least modern day and age, we kind of separate the subjects when they're like supposed to be met with each other, well, when they're meant for each other, I mean to say. And what I mean for that is that a lot of mathematics courses, I don't know, maybe some of you have gone higher up in the branches and you're just, watching this for, for laughs, but basically pure math courses, it's just math. There's really no applications. It's just very abstract, and a lot of these things you'll actually find in, many science disciplines. So what I hope to do here is that, it's going to be a little different than probably what you usually expect, but basically what I'm aiming at is actually giving you like applications for these things. Not just, find the determinant of this matrix and that will give me a nice number, and that really tells me nothing. Now, if I was to say something like, oh, we have some sort of chemical formula in chemistry and we want to balance this. How about we balance this with linear algebra? Well, that's a whole different subject now. Now we can actually use our linear algebra techniques to actually balance a chemical equation, and, you know, they can get very complex very quick, and the most efficient way is to use linear algebra. And you'll find this, you know, in physics as well as engineering. I might do, you know, some force problems, you know, thermo problems, mechanic problems, stuff like this. Like, really what I'm, you know, looking at is that I'm going to have a concept video, and then I'm going to do, you know, multiple examples. In the concept video, it will just really be the concept, but in the examples, they'll actually be real examples, so you can really grasp the concepts. So, basically, you know, leaving this, what sort of perspective should you take on mathematics in general? Well, after taking this, you should be able to solve linear equations very efficiently. I know, especially if you go higher, let's say you go to things like calculus, or, you know, I guess a good example would be something like, you know, multivariable calculus. You know, there's these things called gradient vectors where you find, like, the instantaneous rate of change of a slope on, like, some surface, whatever the hell that means. But basically, you know, you're using a vector and you're using basically a plane to approximate what the instantaneous rate of change to that point is. And this is kind of the strength of linear algebra. Basically, what we do is we, like, kind of write equations for planes, and, you know, planes come in very handy, especially, like I just mentioned, in, like, approximating instantaneous rates of change on surfaces. They're very interesting in terms of transformations. You know, if you want to skew planes, or if you want to do, like, linear transformations on them or something like that. Probably what I also want to do is and see, this is going to be really hard for a lot of you, because a lot of you are really stuck in this idea that, you know, X is your independent variable and Y is your dependent variable, and, you know, we have a Cartesian plane and this is where all of our magic works and stuff like that. Well, unfortunately, I'm going to have to, you know, take away your safety blanket from you, and you'll feel, you know, very extremely uncomfortable. But this is very important, because basically in mathematics, if you take the right perspective on a problem, it will be extremely easy. If you take the wrong perspective on a problem, it will be extremely hard. So what I want to do, and this is going to be towards the end most likely, basically I'm going to teach you guys how to, you know, change your idea of not only how variables work. You know, we can interchange variables, you know, it doesn't always have to be X or Y, or, you know, that sort of thing. And also the idea of, you know, like, changing your perspective, right? I mean, really what we do, and especially with the Cartesian plane, we impose coordinates, right? We say that the center is always 0, 0, right? That's kind of like the idea for the classical Cartesian plane. Well, what happens now if I somehow, you know, wanted to change my perspective, and now I said, okay, I don't want the origin to be 0, 0. I want the origin to be 5, 5. And now how will that be? And now how will changing my perspective by making the origin 5, 5, how will that change my perspective of everything around me? Now, I guess quickly I can just put an example to this, but if you look at our solar system, we basically look at the solar system that, you know, the sun's the origin. So, you know, when you look at the sun as the origin, you look at, you know, all of the other planets, you know, going around it, right? Well, if I change my perspective, let's say I made the origin, you know, the Earth now, well, that will change perspective on everything, and now things will move differently, and you'll see different things happen than if you were to treat the sun as the origin, and how you, because basically where your origin is, you treat everything relative to your origin. So that's kind of like one of the strengths of linear algebra, by changing your basis. So I've been rambling here for a while. So I think lastly what I should say is basically, why do you care about linear algebra? What sort of great things in the world can you accomplish with these things? Well, I'm sure probably a lot of people, taking, like, who are watching this video right now, probably a lot of you are involved, I'm sure, in programming or mathematics. Well, if any of you are very interested in gaming, linear algebra really kind of propels this, because, right, if you look at some sort of, game, you have all of these things happening at once, right? And basically what your gaming graphics card is doing is extremely complex linear algebra transformations. Basically, your game, what you're seeing in the 3D, basically what the algorithm of the game is doing is pulling it up to R4, and we'll talk about this later. They basically take it to R4, do matrix multiplications on it very quickly. This is why your game doesn't lag, and because it's so efficient, it brings those calculations from R4 back down to R3, and you see this dynamic world moving. So that's one of the applications of linear algebra, the idea that you can bring things up into higher dimensions and make calculations easier, because it's actually pretty interesting. If they were to do those calculations in a 3D world, it would be a lot more complex and make your game lag, compared to if they bring it up to a 4D world, do their calculations there, then bring it down back to a 3D world. Linear algebra basically is used anywhere you would see linear things. It's used in chemistry. I used the example before to balance these crazy big chemical equations. It's used in things such as physics with momentum and velocities and forces, and that's where we'll go into like differential equations and actually like figuring out solutions to these things, because differential equations are very important in physics to generate good solutions for different functions that you're trying to find solutions for. So that's what I'm going to sum up with. Basically, welcome to linear algebra. I know that it seems like this is going to be a terrible trip, but I suggest that you stay with it. We'll wait a few more days. I'd like for a couple more people that might be interested, to jump on the bandwagon. I originally just thought that maybe, I might get like 2 votes on this thing, and I'm like already up to like 100 people, and like tons of people are like asking me to do this, so that's really great. I mean, like, seriously, guys, like, I'm just doing this because I think it's great that, there's so many people that want to understand this stuff and actually be able to not only learn it, but apply it not only to simple models, but more complex models. So, basically what I expect is that I might get this started by, the end of the week here, or next week, or maybe earlier, counting on, how I'm feeling, I guess. I mean, I could like start doing it like right now. I have no problem doing that, but I'll basically just start, with my concept videos, and then from there I'll go on to, my example problems, and we'll just take it from there. So yeah, I mean, like, what else do I really want to say? I want to say that yeah, like, what I think this whole like University of Reddit thing, I was actually, looking into this, and I really think this is like a great idea, right? I mean, I see on this that, I banter over here, my my mathematics and science and stuff, but I mean, I see like other disciplines such as, biology, well, non-sciences such as, the arts and literature and writing and these sort of things. And I think it's extremely great because, people are like teaching other people skills that, they want to learn. And that's why I'm here, because I want to try to help you guys understand linear algebra and hopefully in the future, understand even more mathematics. So, yeah, I'll leave you here and just comment on the video and tell me what you think. See you later.